Now I am showing in this problem how to find the solution even though it is not required. But sometimes what is the solution the question asked. Okay. So here we got the nature is unique solution. Now I am going to find the unique solution. Note, finding the solution. Okay. Now in the last step, convert into equations. 3 non-zero rows we got, convert into 3 equations back into the form of x1, x2, x3. The first equation is unchanged because first row we didn't apply any operation. Minus x2 plus 3x3 is equal to 1. Say equation 1. Second row gives that second equation equivalent to the given equation. Minus x2 plus x3 is equal to 1. The last one is minus 4x3 is equal to minus 2. Equation 3. Okay. Now I told you the solution variables by putting star symbol in the explanation method got by backward substitution. That means from last equation onwards you will be getting one by one unknown. Okay. From 3, sorry. x3 is equal to 1 by 2. Substitute this x3 value in x2, you will be getting x2 from 2. Minus x2 plus 1 by 2 is equal to 1, which implies x2 is equal to minus half. And 1 implies, substitute these two values in equation 1, you will be getting x1 value. 2x1 minus plus half plus 3x3 3 by 2 is equal to 1, which simplifies to x1 gives minus half. So this is x1 value, this is x2 value, this is x3 value. This is correct or not? Again go back to your given equations. In all the equations substitute in the left side all these 3 things. See that respectively the RHS are getting or not. If your RHS, one of the RHS is not getting after substituting these things, then it is our mistake. Okay. That is. So second problem, unique solution method I am giving. Later you check it whether it is correct or not. This is given 2 marks 2004. The equations 4x plus 6y is equal to 8. 7x plus 6y is equal to 9. Sorry, 7x plus 8y. Comma 3x plus 2y is equal to 1. Have, I am giving the answer in the fill in the blanks, unique solution, later you check. But in this problem I am giving the first step hint. Already that all the 3 equations in standard form. C is equal to A by B is equal to 4, 6, 8, 7, 8, 9, 3, 2, 1. So don't make this element circle immediately the down element zeros using reducing into row echelon form. So here there is a common element. Sometimes depending on the situation you bring the elements into small as possible. That means express in simplest form. R1 dividing with 2. Any number, that means we are multiplying this row 1 by half. Okay. This simplifies to 2, 3, 4, 7, 8, 9, 3, 2, 1. And circling this element, make its lower element 0 as above the previous problem's procedure. You will get unique solution. Okay, just write that hint, first step only. So without dividing this R1, without this step, if you can start by making this 4 elements circled and then its lower element 0, okay, which will take some more time, because you may get in that case big numbers, okay, if you directly start with row operations without this operation, okay, without r1 by 2, if you start directly making the lower element zeros, that is below the element zeros, you may get big numbers. It may takes some more little, that means some more time, that is little bit time. That even though little bit time is also important in entrance. Depending on the situations, you make the elements simpler than the given element, that is simplest, smallest elements if possible. Because I got a common number, that's why I done this operation. Okay, next 3. This is given 2011, 2 marks. The system of equations x plus y plus z is equal to 6, comma, x plus 4y plus 6z is equal to 20, comma, x plus 4y plus lambda z is equal to mu has no solution for values of lambda and mu given by fill in the blanks. We have to find lambda and mu values. Now see this problem, this is a very important problem, logic also. Already equations are in standard form. Here no solution, we need to find lambda mu values for which the equations have no solution. C is equal to A by B is equal to 1, 1, 1, 6. Second equation 1, 4, 6, collecting the coefficients in that level, order 1, 4, lambda, mu. Reduce into row echelon form. So take care about of these type of problems. Always whatever the things lambda, mu, a, b, c going to find, that should be present in the last level only, last row, okay, otherwise operations takes less more time. Some mistakes or some irritation also you will get, some big numbers like that. So here r2 minus r1 reducing into row echelon form, r3 minus r1, 1, 1, 1, 6, 0, 3, 5, 14, 0, 3, lambda minus 1, mu minus 6. Row 1 over, come to second row. This is the first non-zero element. Immediately make its down elements 0, exact down elements, lower elements. So that means we have to do the operation R3 minus R2, which simplifies to the given matrix, the current matrix 1, 1, 1, 6, 0, 3, 5, 14, 0, 0, lambda minus 6, mu minus 20. Now this is the first non-zero element in the first row, first non-zero element in the second row. We cannot circle this element because we don't know lambda mu, that we are going to find. That's why I have given an indication to determine these values, lambda mu. Now the entire problem depends on this last row. That means the both ranks A and C depends on these two last entries. Now look at your question. I have given no solution. That means these equations have no solution. For the corresponding lambda mu values we have to find. No solution means inconsistent. Inconsistent means what I gave the formula in procedure of Ax is equal to B. Inconsistent means rank A not equal to rank C. So that means rank A not equal to rank C means rank A less than rank C, because A is a part of C matrix. So rank A less than rank C, that is rank A not equal to rank C. That means if this element is 0, then closing the column, A has 2 non-zero rows. If this element 0, rank A is equal to 2. Open this element is not equal to 0, that means this is also non-zero row in the C matrix. Okay. Therefore, if lambda minus 6 is equal to 0, that is lambda is equal to 6, and mu minus 20 not equal to 0, that is mu not equal to 20. So what we got the ranks? Then rank A not equal to rank C. See this one, lambda 6, this value 0. So how many circles after closing the last column gives the rank is equal to number of circles, that means number of non-zero rows. That rank A is equal to 2. This element I assumed not equal to 0. That means this is a non-zero row, non-zero row, non-zero row in the entire C matrix after this into row echelon form. Okay, so rank C gives 3. The number of circles, that means number of first non-zero entries in each rows, gives the rank of a matrix in row echelon form after reducing into below the elements, below the elements below the diagonal 0. Okay, that means the number of zeros increases by row by row. Which number of zeros? Before the first non-zero entry of each row. Okay. Therefore, the equations are inconsistent. That is, no solution for lambda is equal to 6 and mu not equal to 20. So after this I am asking 2 questions as above procedure, you do later at home. Okay. First one, for what values of lambda and mu, comma, the equations have a unique solution? Question mark. Second question in the above problem, for what values of lambda and mu, comma, the equations have many solutions, that is infinitely many solutions. So that means these 2 points depends on last row of this matrix. Later you do. So one more question on this model I am giving. 4th problem. This is given 2003. For how many values of A, comma, the equations 1 minus 4, 4, 3 minus 12, 1, 2 minus 8, which is given matrix notation Ax is equal to B, right side is alpha 5, 7. Options. The equations have infinitely many solutions. Options A 0, B 1, C 2, D. Infinitely many. Option is for one value of A only, the given equations have infinitely many solutions. Here also, like that second problem, I am giving first step hint. Your C matrix A by B is equal to 2, 1 minus 4 alpha. Sorry, here not A. The question is for what? How many values of alpha? Earlier I have given A, just modify alpha. 4, 3, minus 12, 5. 1, 2, minus 8, 7. Here this is going to find in the entire problem, but it is located already in the first level. I told you in the previous problem, whatever the things you are going to find, let them bring into last level. That means you interchange the R1 and R3. This is the hint for this problem. Without this step, if you do not apply this step, then you feel difficult also. Complicated. Problem becomes complicated. That means with this step, the matrix changes to 1, 2, minus 8, 7, 4, 3, minus 12, 5, 2, 1, minus 4, alpha. Now circle this element. You know how to make element zeros using the previous problems. Later you do. Answer I given for one value of alpha. It doesn't mean that alpha value 1. One value of alpha. We don't know that alpha value after the reducing into row echelon form. After reducing that matrix into last step, that is row echelon form, then we can find alpha, the corresponding alpha value. That is also according to the option it is given one value only. You check this one. Now I am going to next exercise, homogeneous equations procedure. A small change in this. Solving Ax is equal to O. Homogeneous equations. Point 1. The system Ax is equal to O is always consistent. 2. If rank A is equal to n, that is number of unknowns, then the system Ax is equal to O, that is 0 vector, has trivial, that is simple name 0 solution only. Very, very important, that word only. If rank A is equal to R less than n, n stands for again number of unknowns, comma, then the system Ax is equal to O has non-trivial, that is non-zero solution, and these non-zero solutions are infinitely many. Same as above. In this case, n minus r unknowns to be taken arbitrarily. Also, the system Ax is equal to O, very very important point, has n minus r linearly independent solutions. Copy down. See, the system Ax is equal to O is always consistent. Whenever rights are all 0, all unknowns present in the left side, that equation has compulsory consistent solution exists. One of the solution is compulsory, all are equal to 0, all unknowns equal to 0. Take any one equation, take any two equations, take any number of equations whose right set 0. So all variables equal to 0, that is compulsory one solution. That's why this is always consistent. Now we look for other solution. Whenever rank A is equal to n, number of unknowns, then here no C matrix because right set 0, only A matrix. Find the rank of the given matrix. If that rank is equal to number of unknowns, then the equation system Ax equal to O means given homogeneous equations has trivial, that is 0 solution only, no other solution, that is all variables equal to 0 in the case of whenever you get rank A is equal to number of unknowns, no more solution, you only try it, okay, or I will show you in examples. Next, whenever rank A less than n, rank A is equal to some number less than number of unknowns, then these equations has non-zero solution, that is non-trivial solution, and these non-zero solutions are how many? Many, infinitely many, not finite solutions, okay. In this case, as I explained in the previous topic, n minus r unknowns to be taken arbitrarily to get the infinite solutions, okay. Now, one extra sentence is given in this point that is very important. Recently, I mean in one branch it is asked. Also the system, that is the given equations Ax equal to O has, very very important, n minus r, number of unknowns minus rank of the matrix A, linearly independent solutions. I will explain after two problems the meaning linearly independent solutions. First you by heart these conditions according to ranks, okay, no C matrix, by heart this point, n minus r linearly independent solution. I will show you what are dependent and independent solutions, okay. First by heart these points. Formula for linearly independent solutions, formula for zero solution, formula for non-zero solutions, infinite non-zero solutions according to ranks, and this one n minus r. Problem. This is given 2011, 2 marks. The equations, that is system or simply the equations, 2x1 plus x2 plus x3 is equal to 0, x2 minus x3 is equal to 0, comma x1 plus x2 is equal to 0. 3 equations in 3 unknowns given have option A unique solution, SOL stands for solution. B, no solution, NO, if I put NO dot, that is number, if I put NO only without dot, that is no. Option C, SOL dot means solution, short forms I am writing, infinite number of solutions. SOLS dot means solutions, NO dot means number. D, 5 solutions. So automatically option D is wrong. Either you get single solution or infinite solution. That single solution is 0 solution only in the case of rank A is equal to n. Infinitely many solutions in the case of rank A less than n. Solution. Procedure. What is A matrix? Already equations, all unknowns belongs to left side, right side all equal to 0. 2, 1, 1. In the second equation x1 is absent, that's why its position becomes 0. x2 position 1, x3 position minus 1. In the third equation x1 position means coefficient, x2 coefficient 1, here x3 is absent, that's why its position is 0. Now reducing into row echelon form. Okay, circling, or if possible try to get small elements. I told you 1 minus 1 to make the next steps easy without difficulty and without mistakes also. Okay, now this element already 0, we have to make R3 element 0 with the help of R1. That means apply operation R3 with R1. 2 R3 minus R1, which gives 2 1 1, 0 1 minus 1, 0 1 minus 1. Next step, go to second row, first non-zero element circle and put the arrow. That means we have to apply the operation R3 with R2. R3 minus R2. This simplifies to next step. 2 1 1, 0 1 minus 1, 0 0 0. In the last step, last 0 row. So this is one non-zero element, this is another non-zero element, that is each indicates non-zero row because this is row echelon form, below the arguments are zeros. Okay. Implies rank A is equal to 2 non-zero rows. This is row echelon form. Number of unknowns in the problem 3, that is less than 3. So according to this sentence, this rank is denoted by R, this 3 is number of unknowns. N stands for number of unknowns in this chapter. In the previous chapter, N stands for order of the matrix. Just indicate R and N. So whenever rank A less than number of unknowns, therefore the equations have infinite number of non-zero solutions. Okay. Now I will show you the non-zero solutions. Finding the, actually not required, but I am showing the procedure. Finding the solution. Convert that last matrix into equations with the help of x1, x2, x3. First row is unchanged. The equations are equivalent to 2x1 plus x2 plus x3 is equal to 0. Equation 1. x2 minus x3 is equal to 0. Equation 2. Don't convert again. Don't write the given equations. What is the use of finding the solution? What is the use of making these operations? Convert the last step. Once you decide the rank, the last corresponding step into equations. That gives the solution. Here how many unknowns? N is equal to 3. How many equations? 2 equations. Okay. So I told you in this case n minus r unknowns to be taken arbitrarily. So n minus r, how much? 3 minus 2 is equal to 1. 1 unknown to be taken arbitrarily means don't put some number x2 is equal to 1, x3 is equal to 0 like that. Out of x1, x2, x3, any one unknown is equal to some k. Say any arbitrary constant. That means k, a, l, any letter whatever you like. Then all others are obtained by backward substitution. I shown you in the previous chapter. First problem ax is equal to b. Backward substitution. Okay. Generally, which unknown to be taken? Preferably last unknowns. Out of x1, x2, x3, which is last unknown? x3. But not required like that only. Preferably last unknowns. Okay. Otherwise, in some problems, you may take that means in some problems we may take that x1 or x2, one of these unknowns also. But almost all the problems preferably last of the unknowns taken arbitrarily. Arbitrarily means, see, let x3 is equal to k. Which of these last unknowns? x3. I have taken k. I have not taken a fixed number 1, 0. Okay. K is any number, small number, large number, fraction, integer, negative numbers, positive numbers, any number. Okay. Then from 2, x2 is equal to k, and from 1, comma 2x1 plus k is equal to 0. That means x1 is equal to minus k. Please put the tick for all the unknowns. So this is the way of expressing many solutions, infinitely many solutions through arbitrary. That means assign a new letter, whatever you like, K, A. All other unknowns also got by that new letter. That is called arbitrary. So put the tick, C, option. Copy down. This is first point. So therefore, solution is putting in the capital X. You know that capital X is a column matrix. x1, x2, x3 instead of x, y, z. It is given x1, x2, x3. Substitute x1, x2, x3, keeping the common outside. That means minus 1, 1, 1. I am keeping k outside, where k is arbitrary constant. That is any number, 0 or non-zero number. But here we look for non-zero solutions, infinite number of solutions. That is 0 solution or non-zero solution. K is any number. This is the procedure to express the equations in after deciding the rank, the solution, the way to find infinite number of solutions. Whenever n minus r is equal to 1, one unknown to be taken arbitrarily. In some problems, the difference n minus r is equal to 2. That means in that problem, 2 unknowns to be taken arbitrarily. So one important point I have given, how to find the number of linearly independent solution. That is also given by n minus r. Two. Give any one non-zero value 2k, comma, we get the corresponding linearly independent solution. I will explain independent, dependent. Okay. Just see. Suppose in some problem 1 2, a solution is denoted by x1 1 2, two unknowns problem. x2 is equal to 2 4, x3 is equal to 3 6, etc. Now, the second solution is obtained by first solution by multiplying 2 with all the numbers. The third solution is obtained from first solution by multiplying with 2. That means one solution is dependent on other. This solution is obtained by multiplying with 3 by 2. Correct or not? So, whenever a solution is equal to a number into another solution, that solutions are called dependent. Otherwise, it is called independent. Solutions means putting in finally in the form of columns. That columns are also called, I told you, vectors, rows and columns. To say the vectors, rows and columns are dependent or independent, if any one solution, okay, first let me talk about solutions. Any one solution is obtained as a scalar multiple of another solution. That means one solution is equal to a number into another solution. That solutions are called dependent. Otherwise, the solutions are called independent. So, giving 1 by 1 k value, if you get like these solutions, treating all these solutions are called dependent. Individually taking 1 by 1, which is called independent solution. So, the procedure for finding the number of linear independent solution is n minus r. N minus r is equal to 3 minus 2 is equal to 1. Linearly independent solution. So, how many linearly independent solutions? Only one. That I told you in the second point. Give any one non-zero value to k. That means k is any number. Giving 1 by 1 value to k, you will be getting x1, x2, x3 answers. So many answers. Okay. For any one non-zero value to k, you will be getting one answer, that is called linearly independent. Okay. Now, if you give two values to k, you will be getting two solutions. The two solutions become dependent because one solution is equal to a number into another solution. The two solutions are called dependent. Okay. So, like that, if you go on giving 1 by 1 to k value, you will be getting 1 by 1 solutions. All these solutions at a time are called dependent. But if you take any one of these solutions, that is called independent. Okay. Because I gave the formula n minus r is equal to 1, linearly independent solution. Second problem in homogeneous I am giving. This is asked 1994. Find the number of linearly independent solutions of the equations given in matrix notation 1 0 2, 1 minus 1 0, 2 2 minus 2 0 into x y z is equal to 0. Just I am giving the hint. First step, find, that means perform the matrix A. 1 0 2, 1 minus 1 0, 2 minus 2 0. So just in the previous problem, third note point I have given, number of linear independent solution formula is n minus r. That means you find first of all r, rank of the matrix A. Number of unknowns is 3. n minus r difference is called the number of linearly independent solution. Okay. So you go on doing, you will be getting, I am giving the last step hint, rank A is equal to 2. So this is your r. Okay. N is equal to 3, number of unknowns. Therefore n minus r is equal to 3 minus 2 is equal to 1. Li, short form is Li, full form is linearly independent solutions. As above, just you check after finding rank. Write the main steps. At home you check. So in this homogeneous equation, second model of question is, the equations have some solution, either zero solution or non-zero solution, but we have to find some k, some a for what values of alpha, which we have done in third problem of ax is equal to b, alpha beta values. Similarly here also that type of problems, but alternative method I am giving, okay, for that procedures. The system of equations ax is equal to O possess a non-zero solution. IFF stands for if and only if determinant A is equal to 0. 2. The system Ax is equal to O possess a zero solution if and only if determinant A not equal to 0. Very important point, note point, make it down. Now see, so whenever we need to find some value of k or lambda in the homogeneous equations which is given, no zero solution only or non-zero solutions, in such cases this procedure helps a lot. The homogeneous equations, that is ax equal to possess a non-zero solution if and only if determinant A equal to 0. We have solved so many two problems, okay, just in the previous problem we got non-zero solution, okay, in that case determinant A is equal to 0, you check later. Whenever it has a zero solution, then determinant A not equal to 0. So one problem which is given 2013 1. For what values of P, comma, the equations Px plus y plus z is equal to 0, comma 2x plus y minus 2z is equal to 0, comma x plus 2y minus 3z is equal to 0. Have non-trivial solution? Question mark. Answer. Non-trivial solution means non-zero solution. What is the procedure I have given? Determinant A equal to 0. For non-trivial, that is non-zero solution, we have determinant A is equal to 0. Already the equations are in standard form. All unknowns belongs to left side, zeros belongs to right side. What is the determinant of the equations? That means the matrix A, P, 1, collect all x, y, z coefficients, write in row wise. 1, 2, minus 3, sorry, I have done a mistake. In the first row, coefficients are P, 1, 1. In the second row, 2, 1, minus 2. In the third row, 1, 2, minus 3. Expand the determinant using the procedure, you will get P values, which implies P into minus 3 plus 4, that is 1. Second, 1 with minus into, close the second column, first row, minus 6 plus 2, minus 4. Last element plus into 1 into, close the first row and third column, 4 minus 1, 3 is equal to 0. Plus 4 plus 3 plus 7, so 7 goes to that side, becomes minus 7. Please check later the determinant is correct or not. So for this value of P, the equations have non-trivial solution. One more question I am giving, later you check. Second problem. For what values of k, comma, the equations x minus 2y plus z is equal to 0, comma 2x minus y plus 3z is equal to 0, comma lambda x plus y minus z is equal to 0, sorry, not lambda, kx, have trivial solution as the only solution. Okay, so here trivial solution means zero solution. So I am giving the hint. For trivial, that is zero solution only, what I gave the note point, second note point, trivial solution, zero solution means determinant A not equal to 0. Expand the determinant after writing the A matrix as above, you will get, instead of is equal to, you will get last step k not equal to some number.